Greetings to everyone in a fitting manner. This will be the second to last video in the series, at least for this year, since
and winter is coming.
I just realized that I have footage of the well water level sensor, so I will include it here. It was done previously between the second and the third video, but better late than never. I also plan to continue the backroom piping stuff, but I have a lot of footage about the well meter and I don't want to create such long videos. So let's dig in. The next part of the well project is to figure out how to measure the actual water level in the well. Since it's already done in the water tanks, it's not a big challenge, let's say. So I already bought a 6 meter long cable, this sensor, which has a 24 volt input and a signal from 0 to 5 volt, and it measures the water level, how many centimeter of water is in the top of the sensor. From that, with some basic math, it's easy to calculate out the actual water, the amount of the water in the well, as it was easy to calculate it in the tank. The other two cable, which is needed, had to be wired inside this box, is this temperature sensor. I'm just curious how the temperature is going in the winter and the summer. So yeah, I also have this one and this biggest one, which will be the input of the Ethernet itself. So it will get power from here. Since all the three has to be drilled, yeah, it has terrible sound, sorry. I need to measure them. I measured that too, but it was a long time ago, and I need 3. So it definitely needs to be rethinked. Yeah, 28 is for that one. The 18 is for this one. And I have a last contestant, which is 12 millimeter. Nice. So I need 12 here in the middle. Okay. Yes, more chaos in my task because I'm in multiple projects. I'm also not the best of housekeeping. So okay, I find my cutting drill. Oh. I don't know if it's seeable or not, but I like to mark. This way I can see where am I, because it's so easy to screw up this drill. Okay, the last one will be the biggest. If I not messed up, then it's ready. Almost ready. I need to deburr this holes, but yeah, almost ready. Okay. Okay, let's see. If I try to summarize what will need to be done, first I figure out some sort of holding. I need to figure out how to hang this inside the valve, because it must be watertight. So drilling the back, drilling the top and drilling the sides are not, it won't be done. My idea is to print something, but possibly I cannot print it in one go, so I don't have big enough printer to create these. My idea was to print a middle plane. I can print 14. Yeah. Okay. So I need to design something here which has, so there will be 1 or 2 screws in the bottom and in the top, possibly in the top because it's hard to assemble and disassemble, but I don't need to go that deep with this one. So I will create some straight stuff with an out hanging over the box, and this straight stuff will be screwed to here with some spacers, and I will fill up this with hot glue, with a right amount of hot glue. It possibly will do the job. I really hope it will do the job. Yeah, and it will be hanged via a screw. Actually, if it falls out, the UTP cable possibly will catch it, so I'm not that worried that it will fall to the well. Also, it can be easy to fish out, at least with the right tool. You can possibly get in touch under. Okay, so about the electronics, I need an ESP32 here. I need an Ethernet connector. I also need a power supply and with PoE, and I need level converter and an ADC to have better measurements from the sensor, because the internal ADC is I only have 3.3 volt and it's 4096 bits, but because the 3.3 volt threshold, I need to use a voltage divider, so the 5 volt will be dropped down to 3.3. It has temperature dependency there also. Because of that, the actual resolution will not be that good. So as I replaced it in the water tanks, the ADC, I will replace it here too, and we will see. So yeah, I don't really decided that either I would like to create a PCB and take time designing and milling, or I just use a breadboard, or I mean a prototype board? Yeah, it's a good question. Also, I need to create a piece of plastic here because I don't want to screw through the box. So those will be held by these screws, and I will screw the PCBs to that. Okay, we will continue. So I need to design something for the box which will hang with some water barrier. So the actual concept is that I will also try to learn Fusion 360, because for not commercial use it looks like a good option. A lot of YouTubers and a lot of other people using it. I am familiar with the Solid Edge, and possibly it will be the ever best designer for my usage, because I know it not that deep, but for a normal usage, whatever. So I doesn't want to create a tutorial or anything with the Fusion 360 because I'm not the guy who can tutor you. But yeah, you will see how I design the different parts, and possibly I will start learning the Fusion 360 too. So everything is done for this project. I need the preparation for the well meter. For that I will use some CH glue. If I'm right, it won't be necessary to remove those. Okay. So this PCB will go here. The power supply, which will do 5 volt from the 20-ish, will go here. And as I mentioned, I finished milling the PCB, but eventually you will see, or you already seen this. But before I continue assembling this one, I must start assembling. So the first step is to open up the Eagle and start heating up my soldering iron. Okay, it's working. And if I pull the DC to the ground, 0.00019 volt is measured. Nice. Okay. So the quick overlook here. This panel will goes in. It will be on legs for that one. The Ethernet, the temperature sensor. So the LAN, the temperature sensor and the water level sensor will come here. I also need to drill a little hole because the temperatures, I mean the water sensor actually will increase the pressure if I'm not doing this. So there will be a small hole, I must drill it.
It's everything at one time.
So if I did everything right, click. Okay, the device is online. It's definitely a good sign. The temperature reading, okay. And yeah, the water sensor don't have the connector on it, so whatever. So this is the minus, this one is the signal, and the middle is of course the plus. So the technique is working, and I have very little steps back because it will be screwed up here. I need to pull down up the wires. I need to drill 2 4mm holes up there and assemble this holder part, which will be screwed into the well from the inside. I will continue the assembly tomorrow because it's almost 3 o'clock AM. Okay. We will continue. Bye. I have drilled these 2 holes here, and I'm starting to assemble this back pane or border part. Okay, so the box is here. I need to put the Ethernet cable in. I need to push a head rattler, and also I have a PoE injector. So I will stick the camera here, far away from the well. Okay. So here is the box. Yeah. This is an update about the well meter, 5th of January 2026. So let's have a look how it ended up in the Home Assistant. So as you can see, there are a few stuff written out of the current state of the well. The analog digital voltage is the red voltage from the sensor. This is converted to percentage, to centimeters, and from that to liters. And also we have the temperature sensor in the well, so I can monitor the temperature. It's not that important, but I was curious. So here's the temperature graph, just for curiosity. But maybe it's much more better if I show you the... it was installed somewhere here. Let's wait. Okay, so the measurement starts from August. Yeah, I had to wipe it or it just ran into the timer. I don't know. Whatever, as you can see, we used 4 times the well last the mid-September, but now the rows are not finished, so we did not plant any vegetables. I mean, we have some tomatoes and pepper, but nothing extra. Mostly the water went to the trees. But yeah, I can monitor it, and as you can see, we still have more than 600 liters of water. About the code, so it's an ESP32 just directed thermostatic radiator valve controller. It's the same PCB actually, with some modifications. So I have the Ethernet port, I have one wire and the I2C. The I2C is for the ADC, the one wire is for the temperature sensor. I have the restart button because sometimes the API disconnects, not with the Ethernet ones, but with the Wi-Fi ones, so I just put a restart button there because it's usually working. The MQTT is connected back, usually. The API, sometimes not. So yeah, we have the Dallas temperature sensor, we have the ADC. The ADC itself is used, the ADC value, to calculate the water column level, the height of the water column, and it's done with these 3 mappings. These mappings were done outside of the well, of course, in a 1.5 liter bottle. From the from the centimeter value, I can calculate the percentage, but this percentage mean if it 100%, that means it's almost overflowing the actual well, so it never be more than 50%. But I don't know where the top is, where the water can rise. So yeah, I let it there, and from the centimeter value as well, if I divide it with 100, multiply with pi, and the square of the radius of the inner diameter of the well, and of course if I multiply with, yeah, from that we can get cubic meters, but if I multiply with 1000 I can get liters. So this value is sent in every 10 seconds to the Home Assistant, and I can monitor the actual water level by that. Please don't forget to like, share, subscribe, and hit the notification bell. You can support my projects on Patreon, or you can buy me a coffee or some new ESP32s. And as always, let's keep the smoke inside. Bye bye.